This is a question from GATE 2023. Let's see 0, 1 denote a set of all real valued continuous function defined on 0, 1 closed interval. And f with infinity norm is the supreme of all fx modulus x belongs to 0, 1 for all f belongs to c0, 1. This is supreme norm, famous supreme norm, and we define the set x as those f belongs to c0, 1 such that f0 is equal to f1 is equal to 0. Now we define a function from this set with this norm fc01 from infinity norm to r by f is equal to 0, 1 ft dt for all f belong to c01. Then we wrote another set sx. So there are two sets here. First is x, then is sx. Sx is defined as those f whose infinity norm is 1. So we are asked the question that then the set f belongs to x, these f continuous and f at 0, at 1 and 0 such that the function value of these f is equal to the norm of capital F intersection Sx. So the element must be in this both sets, and we are asked exactly one element. So simple question is how many elements are there in this set. Okay, first of all we can see that we need to know what is this. So first step, what is this? What is its value? So we can see that f is a function from c0 in 1 space to the r. So we take its modulus and it is 0, 1 ft dt, and we will use this famous inequality. This goes inside dt, and yeah, this is less than f infinity. This value will be 1. Okay, what we have done in this steps from here to here is that we have used that f infinity norm is always greater than ft. Okay, we have obtained this. So we have capital F modulus is less than equal to f infinity, and we have f norm into f infinity. So what does this show? This shows that from the definition of the norm, f modulus should be less than equal to 1. Okay, now we see this result. We put this relation is true for all f belongs to c01. So we take a simple f to make it easy calculation. So we take f is equal to 1. So what is f1? F into 1 infinity norm. 1 infinity norm is equal to 1. This is equal to 1. You can check it yourself. No big deal. Sup norm of 1 is one function. This is function, constant function whose value is 1 for all x. And now we need to evaluate f1. What is this? From the definition of f, this will be 1 dt 0 to 1. This is equal to 1 2. So 1 is less than equal to f infinity dot 1. This implies 1 f norm is greater than 1, f norm is less than 1, f norm is greater than 1. This call it A, call this B. From A and B, f norm is equal to 1. So we have evaluated that this f norm is 1. So let me write this whole set again. Okay, the set was f belongs to x such that f is equal to f norm, which is equal to 1, intersection sx. What was x? X was those f belongs to C01 such that f0 is equal to f1 is equal to z. What is sx? Sx is equal to f belongs to x, those f such that f infinity is equal to 1. Okay, let's just assume that if some g belongs to this, then fg is equal to 1, because this is from this set, and g belongs to sx because it belongs to the intersection of both. So what should we have? We have g infinity norm is equal to 1. Fg is equal to 1 implies gt 0 to 1 dt is equal to 1 and g infinity norm is equal to 1. Also note that g belongs to x2. So g0 is equal to g1 is equal to 0 from definition of x. Let me rewrite everything. So if g is a function in the required set, then what does property g have? gt01 dt is equal to 1. Second, g infinity norm is equal to 1. This implies supremum of gt modulus t belongs to 0 1 is equal to 1. Third, we have g is continuous to, because we are in continuous space. Fourth, g0 is equal to g1 is equal to 0. And my question is it possible for a continuous function? Is it possible for a function to satisfy all these properties? Let's just try to make it. Let's consider this is 0 and this is 1. Let function be like this. And since its supremum is 1, it can go only 1. And we need this area. We need this area to be equal to 1. But this area is always less than this area. This area will be always less. This area will be always less than 1 because 1 is the whole this area. So in this case, it is not possible. Let us try to make some other cases too. What if we have like this? It can go mostly to -1 because we have this condition gt is less than 1 for all t belongs to 0 1. It can mainly go to -1 and then it can go again to 1 only. This could be another possibility. But again, this area, this will cancel each other. So it cannot be, it can never be equal to this area because this will be minus, it will be negative, this will be positive. So it will make it less, more. So it cannot be equal to 1. So in any case, It is not possible to have a function 0 1 gt dt is equal to 1. The area 0 to 1 is 1 and its supreme value is also 1. It cannot go beyond than 1 minus 1, and g0 is equal to g1 is equal to 0 and g is continuous to. Not possible. So no element can lie. This implies there is no element which is possible here because we have taken g to be arbitrary element in this. So answer, so its solution is A, no element.